SK stands for Square Kilometer Array. It is the world's largest radio telescope. It will cost about $5 billion to build. And South Africa was bidding to host this against countries such as Argentina, Australia, America, Canada, China. And the reason why they won in the end, now part of it was because they had very cheap electricity, but the reason why they won is because they had a site that's high and dry. If you're high and dry, basically what it means is very little atmosphere. You don't want to have rain clouds and stuff like that because it attenuates the signals coming from space. So I got to work on the lobbying aspect of that, and part of that lobbying aspect, I had to figure out ways to convince our African partner countries to be more involved in the project so that we would win, we would be successful. And the way to do that, in the end, was to invent a whole new telescope. So it was a lobbying strategy, but the African VLBI network, this thing here, ABN, was an invention, was a figment of my imagination, pure and simple. And it was designed so I could convince Mozambique or Botswana or Namibia or Ghana to be more active in the project, because one of my economics models was telling me they weren't willing to do anything because for them doing nothing meant they got the maximum economic return from their investment. If they invested nothing and we won the bid, they got everything. If they invested nothing and we didn't win the bid, they lost nothing. So I had to change the equation. It's called the prisoner's dilemma. And the way to do that was we invented a whole new telescope. Now, lucky for me, we were also able to convince one of the departments in South Africa to put money forward. So we were able to start building the African VLBI network. And that network is a series of radio telescopes around Africa, firstly in the African partner countries for the SKA, and then hopefully in the longer term in other countries such as Tanzania. The first telescope is being completed now. It's a converted a telecommunications antenna. A radio telescope and a telecommunications antenna are exactly the same. The only difference is I point at the stars, they point at satellites. And mine moves around a lot more, okay? So we invented a telescope to help South Africa win a bid, and it did help. It helped the African countries to be more involved because they believed they would be next in getting a telescope. And me, the astronomer side of me, said, I get to use a world-class telescope in Africa, built by Africa, for Africa. And that was the intention of the AVN. Regrettably, politics always enters science. And the AVN is controlled by a group of people who want to build an extension of the Square Kilometer Array, the SKA. They want outstations to be part of their Square Kilometer Array, and therefore they will control these telescopes. I didn't bother telling them that African countries are independent and will do as they please, because I didn't have to. I know better. I know Ghana's going to tell them to go bugger off eventually, and I'm going to look at a star-forming region, or I'm going to look at a galaxy, or do what they want to do. So I let them do their own thing, and I'm happy with it. But other objects that we did build, and this is part of the radio astronomy development in South Africa, in particular South Africa, was we built a test instrument, which was very bad, by the way. It was a really poorly designed and built telescope. They handed it over to Hartrail, and we had to fix it. So it was just, the problem in the SK project is engineers. Great guys, they're doing good work, but they learn through mistakes. And engineering, astronomy in particular, just as a matter of interest, is R&D engineering on steroids. So if you do mechanical engineering, if you do material sciences, astronomy is excellent, because the material science is going into building the next generation of telescopes is at the cutting edge of everything that we do. The electronics is at the cutting edge of everything we do. Signal processing, computing. So for instance, the Square Kilometer Array, its only benefit to South Africa, its real benefit to South Africa, is the high-speed computing. It will require the world's fastest supercomputer. Okay? So that's what it'll do. Anyway, and long story, and now we're left with millimeter astronomy. It's the last piece of the astronomical puzzle that's not here in Southern Africa, in Africa in general. We do not have millimeter astronomy, and I thought about this about 20-odd years ago. And when I was at a meeting with a group of delegates from the Department of Science, Communications, Science and Technology from Tanzania, I remember I thought to myself, this is an opportunity to ask, could we not put a millimeter telescope on Kilimanjaro? And that's what we proposed back in 2010, and they actually were quite interested. And when I left the room, they said, well, what can you do? And I said, well, I'll send emails to friends of mine in the US and Europe. And the next day, 24 hours later, I was offered a $20 million telescope to go on to Kilimanjaro. That was the excitement of the world. for millimeter astronomy and to put it at a site like 4,000 plus meters on top of Kilimanjaro. Not on Uhuru Peak, let's be serious here. Not where the tourists go, but rather on the plateau or on Mwenzi Peak, okay? But they got very excited about the possibility, and that's where they were. So that's where we are today. We're busy trying, I'm here with my colleague, we're busy trying to get permissions to put test equipment on Kilimanjaro so we can test to see if it's an excellent site for astronomy. Our desktop study tells us, with satellite weather data, tells us it's probably one of the second or third best sites in the world. So, and just to give you an idea of the economy, make no mistake, astronomy is a business. It's not just a science, it's a business. A telescope, one of the world's largest optical telescope being built right now is worth $1 billion US, okay? That was meant to go on to Hawaii, and they now have a court interdict to stop the construction. They now have to find a new site. And it could have been Kilimanjaro if we were lucky. If we could have actually been building a 30 meter optical telescope on top of Kilimanjaro. It would have been a possibility if we could have proved it's a good enough site already. Okay? So we are testing sites. That's our goal. That's why I'm here now. Okay? So now here's part of the telescope I was telling you about. So the African VLBI network is a series of telescopes. And again, I told you, it was designed as a lobbying strategy, not a telescope. So the intention was never to build this telescope. The politicians did not want to build this telescope. They just wanted to convince Ghana to be more supportive of the African bid. So we created a lobbying strategy. It's bizarre, just bizarre, but it worked. Anyways, regardless of that fact, my good friend Dr. Mike Gaillard, and he's passed away now of cancer, unfortunately, he actually went around and he realized there were lots of these big other antennas all over Africa. So he was talking to a friend of mine from this guy here, Lamek. He's from Namibia. He's a Zambian born, working in Namibia at the Polytechnic in Namibia, one of the African partner countries in the SK. And he said, oh no, we have one of these 30 meters in our backyard in Zambia. And Mike goes, what? And he realized there must be more all over the continent. And if you take 5 of these and you link them up, here's South Africa, that's where I live, that's where I work, and you take the ones in Zambia, this is Zimbabwe, I think it's Zambia, Kenya, well, whatever, Kenya's up here, here's Ghana up here, Madagascar, you can suddenly create a network of telescopes that will rival any network in the world. And you can have one of the best VLBI networks in the world that will produce images of the sky at such high resolution, we can then start looking at really interesting objects. Me, I look at stars being born. Okay? Others look at galaxies. Other people look at black holes, or try to. Okay? Those are called, and so what I mean by VLBI, it means very long baseline interferometry. So, here we go. Here we have 2 telescopes. Here's telescope 1 in Africa at Hartreo in South Africa, and this one is in Australia. Okay? The resolution you get is the wavelength you're operating at, observing at the exact same time, the same source, is the resolution is the wavelength divided by the baseline distance between the two. So you can do 2 things. You can either make a map of the sky with this, very high resolution, very small objects, or you can do the opposite. You can figure out when the signal arrived here and there, and the difference gives you the baseline distance. So we can do anybody heard of continental drift? You know, geodesy, that the continents are drifting apart? We measure that at Hartreo. So we know here towards the Rift Valley is being torn off of Africa. So very soon there will be an ocean between the east and west part of the Rift Valley because it will be torn off. And South Africa itself is heading towards India at about 3 to 5 centimeters a year. It's just slowly drifting towards India. Okay? And we don't even know what's happening in the rest of Africa because we only have Hartreo in South Africa. We don't have a big telescope in Ethiopia, in whatever, and so on and so on. Okay? So these are experiments that can be done using radio telescopes, and they're being done using the technology called very long baseline interferometry. And it's important for Kilimanjaro because we want to look at the black hole at the center of our universe, our galaxy. We need to have very long baseline interferometry at millimeter wavelengths. Okay, so that's the story. And so Literally, my friend Mike Gaylord used stamps to find these big telescopes all over Africa, and there's 28 of them, I think, in 23 countries, something like that. Some of them have been destroyed already. Some, like Ghana, are being converted already, and others they're now discussing with us to convert them. So it's possible we'll have a network of telescopes in Africa that will do science for Africa, with Africa, okay? And as I said, not designed to be built originally. So here's all the people involved, and remember, astronomy is a team. It's engineers, it's educators, it's scientists, it's government officials. It takes a team of hundreds to make telescopes work. Astronomy is not simply looking at the stars. You have to have an engineer that knows how to keep the telescope working. You have to have a digital engineer these days, a software engineer. You have to have all sorts of interesting people. They do very different science. So in a room, you'll have, this guy's an educator. This is our engineer from India. You see our group here in Ghana itself. This is my good friend Adelaide. I'm her child. I'm the godfather of her child. So I'm very proud of her and her son. This is the minister from Science and Technology in Ghana. And she recognized the opportunity right off the bat and said, we can get this antenna and then we can convert it. And so that was the first telescope that we converted with Ghana. And I got to tell you, for science purposes, I would never have chosen Ghana first. Never. It's right at the coast. It's right beside a big city. So it's got high humidity, salt air, lots of people, lots of noise, lots of radio noise, microwave ovens. This microphone is Wi-Fi. This is a big no-no in astronomy. You can't have this at my observatory. You can't have cell phones at my observatory. Okay? So you don't want people around the observatory. Anyways, but this is what the ABN was, and this is what can happen here in Ghana, in Tanzania, should we build a telescope. So here's examples of other big telescopes. You can see them here. Let me see if my fingers are. Here's Madagascar. This one is Zambia, and here is Kenya. This one, by the way, is being destroyed right now. People are buying it for scrap. So we will likely lose the Kenyan site, unfortunately. And this is just examples of some of the science you can do. The interesting part about Southern Africa, in particular north, south of the equator, is that most of the telescopes of the world are all in Europe. They're in Europe or they're in America, but none of them, very few are in the Southern Hemisphere. So you've got Australia, and that's it. Okay, you got one in Africa, that's it. They're building new ones, but you got one in Africa. But 2/3 of the sky is missing from the northern telescopes. So you can sort of see all of this stuff. This is what was done by the northern telescopes. Everything else down here is invisible to them. It's below the horizon. So we sit in the pound seats. We sit where we can do excellent science. So Africa is well suited to do excellent science, especially if we built a network of telescopes across the continent, north and south of the equator. Then we could do both skies. Okay? The object here, you can see, is its proper motion studies of a pulsar. A pulsar is a spinning star, all-star spin, but this star is 10 kilometers in diameter, and it spins 1,000 times a second. And it gives off a radio beam, like a lighthouse. So you have this, think of a lighthouse coming around every 1,000th of a second. That's all it is, okay? And you can measure that like an accurate clock, and then you can see its motions because it's actually moving around the sky, and the motions are the result of the black hole at the very center of our galaxy. So we can see the black hole, its effect on these pulsars, these groups of pulsars. They're being affected by the gravity. Okay? So those are examples of some of the science that we can do. And this is a bit more